Hello, if you've just joined us, I see there's a few more people that are still joining from the waiting room. But in the meantime, we can get started here. Hello, you've heard my voice talking, but my name is Cassidy and I am with the Edmonton Public Library. And I'm really happy to be helping run these online speaker series that we were able to move to a virtual platform with the libraries currently being closed. I just wanted to welcome everyone and to let you know a few housekeeping things. So we are recording this session. The recording will be available afterwards. So if you do have to step away or you miss something, there'll be a chance to view it on the Future Energy Systems YouTube, which I will mail out via email after the presentation. But that also means that just to be aware, at the end, if you are asking questions and you pop on video, there's a chance that your voice and image may be captured in that recording. If that's an issue, there'll be an opportunity to be able to ask questions via the chat without that. The other thing is just for the courtesy of our speakers, if you can keep your microphone muted until there's an opportunity to ask questions, that would be greatly appreciated. Other than that, I hope that you enjoy this evening and join us for any of our other future talks, either with the energy systems or with other partners with the library. I'm going to pass it over to Valerie Miller, and she's going to introduce our topic and our speakers this evening.
Thank you so much, Cassidy. Hello, everyone. Welcome to Energy Talks Online, New Year, New Tech. My name is Valerie Miller, and I'm the Outreach and Engagement Coordinator for Future Energy Systems. Welcome to the first session of our second year of Energy Talks, actually. We started January last year, had a little bit of a pause for COVID, but now we're back and raring with a full year of talks planned. You'll also be meeting Kenneth Tam later tonight, the Communications Manager of Future Energy Systems. So first, I'd just like to say the university, oh, and he's waving now. And our speakers are also on camera. We will be introducing them in a second. So first, the University of Alberta would like to acknowledge that we are located on Treaty 6 territory and respects the histories, languages, and cultures of First Nations, Métis, Inuit, and all First Peoples of Canada, whose presence continues to enrich our vibrant community. So to just give you a little bit of a background into Future Energy Systems, we were launched in 2016 with a $75 million grant from the Government of Canada's Canada First Research Excellence Fund to help Canada transition to a low net carbon energy economy. We focus on multidisciplinary research that develops energy technologies of the near future, 3 of which you're going to hear about tonight, so get excited, integrates them into today's infrastructure, and examines possible consequences for the economy, environment, and society. We also contribute to the development of solutions for challenges presented by our current energy system. So there are over 100 research projects in 14 themes spread throughout 10 faculties at the University of Alberta. There are over 140 researchers involved and over 750 graduate students, postdoctoral fellows, and other highly qualified personnel. So we're pretty big, and we've got our tendrils everywhere, which is a lot of fun. We get to see work from all over. So tonight you're here for a special event. We have an opportunity to explore 3 new energy technologies. I'm going to introduce each of our wonderful speakers and then play a video where they each took 5 minutes to share their work. If you have any issues viewing that video with audio, or if it's glitching, just send a message in the chat and we'll send you the link to YouTube and you can watch it there. After that video, all of our speakers, Kenneth and myself, will come back on screen, and for the next 45 to 60 minutes, we're going to answer all of your questions and have a discussion. You can submit your questions in the chat box during the video or in that question period, and I will share those questions with the speakers. So first, we're going to meet our speakers. So Dr. Yeling Zhu will be talking about from waste grease to your next flight trip. Dr. Zhu is a postdoctoral researcher from the University of Alberta, dedicated to providing solutions for agricultural and industrial operators. He has expertise in developing technologies that create value from Alberta's sourced sawdust, waste materials in the cattle rendering industry, and waste grease. He believes that derived smart materials and low carbon fuels help support Alberta's sustainable development. So welcome, Dr. Zhu, tonight. Dr. Bing Tao will be talking about making lithium-ion batteries better, a new anode technology. Dr. Tao holds a PhD in chemistry from the University of Alberta. She has almost 10 years experience in the research and development of new renewable energy materials and devices such as organic solar cells and lithium-ion batteries. She is the CEO and co-founder of Nanode Battery Technologies, which is developing new lithium-ion battery components. Finally, Dr. Zhongyi Chuan will be talking about the evolution of the electrical grid. Dr. Chuan has received his PhD degree in energy systems in 2019, again from the U of A. After a year of postdoc research, he founded the Electronic Grid Systems, a spin-off startup of the U of A, and he's now trying to commercialize the microgrid technologies to make our grid systems greener. So you have a really great opportunity to talk to all these researchers. But before we start, we just want to remind the current and future viewers that the opinions expressed by our speakers are not necessarily those of the Edmonton Public Library, Future Energy Systems, or the University of Alberta. So now all of our videos are going to go away, and we're going to start this exciting mini research talk. So I'm going to ask everyone to turn off their videos and enjoy.
Hello, my name is Yelin Zhu. Today I'm very happy to present you a story from waste oils to your next flight trips. So first, let's take a look at these two yummy photos. French fries and fritters, they are popular foods that we can DIY at home or we can order from a restaurant. I personally like them. But in preparing these foods, a lot of waste cooking oil is generated and has to be disposed. Actually, in addition to these waste cooking oils, there are a lot of low value or waste oil streams. This includes the crop oils and animal fats. So here comes the question: what kind of value can we create from of these waste or low value oil feedstocks? My answer to that is a biofuel. Using a patented technology that was developed here at U of A, we can successfully convert these low value or waste oils into drop-in diesels. But what if we want more? We further decided to move on to the application of a more difficult direction, that is the biojet fuel, based on what we have achieved. What makes the biojet fuel different or unique from the common drop-in diesel? That is the cold flow property. As we know, plane flies high in the air, which can be up to 35,000 feet from the ground. And that high altitude, the temperature can be as low as minus 55 degrees Celsius. That is extremely cold. And common fuels at that temperature will form a gel or get frozen inside of the fuel tank, so it doesn't work. The reason for that comes from the structure of the fuel molecules. For common fuels, a lot of its molecules is in the straight form or linear form. These types of molecules can be orderly packed at low temperature, which will restrict their movements. So in this case, the cold flow property is not good. My work focusing on introducing branches into these straight molecules or side chains. With all these branches or side chains, these molecules will stay more active at low temperature, and in this case, they can get an improved cold flow property. We have been working for more than 1 year on this direction, and we have achieved promising results. Our final target focuses on the global aviation fuel market. As a current aviation industry, it actually contributed to 2.5% of the global CO2 emission, which is more than 1 billion tons of CO2 per year. And the global aviation fuel market is expanding very rapidly over time. As we can see, the total market is expected to be expand by more than 50% by the year of 2026, based on the 2018 level. This represents a great opportunity for the green technology development in this area, and I'm confident that our technique will become one of the cornerstones for the future of the aviation fuels. This project is currently led by Dr. David C. Bressler at the U of A, and we are very happy to have received tremendous support from all our collaborators that listed here. If you are more interested in the more details of this project, please feel free to reach out to me, or please refer to the websites listed here. Thank you.
Does anyone want a better battery for your phone? Has anyone experienced the horror that you have an important message to reply, but your phone is just dying? Or has anyone considered buying an electric vehicle but was worried about the limited mileage? The world needs better batteries, not only for EVs, portable electronics, but also for the intermittent energy storage for renewable energy systems. The world is electrifying. Renewable energy is expanding dramatically over the past years. Solar energy itself is expanding with a compound annual growth rate of more than 25%. The United Kingdom, Norway, State of California, and Henan Province in China, among many other cities, are moving towards banning the sale of automobiles, gas-powered automobiles, in less than a decade. This global shift towards a more sustainable world is all underpinned by the technology development of batteries. My name is Bing Cao. I'm CEO and co-founder of Nanode Battery Technologies. Nanode is a spin-off company from the University of Alberta, and our technology is based on recent research from the University of Alberta Research Lab. I'm here to show you how nanode technology can make batteries better. Let me give you a crash course on lithium-ion batteries. A typical battery consists of 3 essential parts: the cathode, the anode, and the separator. The lithium ions then can move back and forth between cathode and anode, then we can charge and discharge the battery and use it. Believe it or not, in the past decades, most of the advancement of battery has been focused on the cathode material, while little research is given to the anode research. At Nanode, our technology is focused on the anode material development because, as you see from this picture, graphite, which is this black carbon powder, is used as the classic anode material in battery for more than 3 decades with minimal change. Now it has come to the time that the cathode material have so much been advanced. We need a better anode technology to match with it in order to make the batteries perform even better. Here is what we do. At Nanode, we make these thin-film metal-based ribbons to replace graphite. Our product not only offers higher energy density than graphite, but also our preparation method is much simpler. Let me explain. What happens for graphite anode preparation is we need to combine the graphite powder with some conductive binders, additives, and organic solvent, mix it together, form a slurry, then cast this slurry onto a copper current collector. Then go through drying and calendering process before it used in the battery. At Nanode, our technology is much simpler. We go from raw material to the final product in one step. We don't use any organic solvent, and our process is dry. Also, the one-step process eliminates the variation that can be introduced in the battery manufacturing process. At Nanode, we adopted this technology called melt spinning. We can make these long and flexible metal ribbons in seconds. Then we cut it into shape and fit in battery manufacture directly. We have demonstrated in lab that our product is 50% better than graphite. Our team consists of scientists, engineers, technical and business mentors from University of Alberta. We are passionate about the technology and we will keep making progress. We are very grateful that we are supported by the community. The Government of Canada, Government of Alberta, the University of Alberta give us great support as we grow. So, if you are interested in your technology, if you want to know more about Nanode, if you want to keep an eye on our growth and progress, if you want to see future Alberta-made high-performance batteries, please keep in touch and contact us. Thank you.
Hi, my name is Zhongyi Kwang, and I am the founder and CEO of Electronic Grid Systems. We're a spin-off of University of Alberta. Today, I'm going to talk about the evolution of the electrical grid system and how it will look like in the future. For over a century, electricity has been an essential part of people's daily life. Without electricity, we cannot do anything. And the system that supplies electricity to our homes is called the electrical grid system. The first grid systems were built in the late 19th century. It all started with a current war between Tesla and Edison. We now know that there are two types of electricity. There is an alternating current, AC, and also a DC, direct current, DC. Edison developed the DC technology, where the current or voltage runs continually in one direction. Well, the Tesla, who once was Edison's employee, believed that AC is the right choice for the electrical grid system because compared to DC, AC can be easily increased to a higher voltage through a transformer and therefore it can be distributed over a long distance. But back then, people did not know how to convert DC into higher or lower voltages. So the system was not efficient because the voltage was too low to distribute power over a long distance. And therefore, the winner of the current war was, of course, Tesla and the AC technology. Well, to recognize Tesla and his greatest invention, a statue of Tesla standing on his AC motor has been built at Niagara Falls, where the first AC power plant was built in 1895. Since then, AC has become the standard in our grid system, and well, we have been relying on that system for over a century now. Well, most people might think that the system will never change, but actually we're on the verge of a revolution in the electrical grid system. Because right now, we can convert DC power now easily with the device called power electronics or power converters. So power converters are a kind of system that can transfer electricity from different forms. For example, from AC to AC with different voltages, from AC to DC, or from DC back to AC, and also, of course, from DC to DC with different voltages. And the efficiency is very high. Sometimes it can be around 99% efficient. So power converters exist everywhere in your cell phones, chargers, all cars, whether it's gasoline or electric, in your home appliance. So basically everywhere that uses electricity. With power converters, we now can generate generate power in the DC form through, for example, solar panels, and we can even transmit power in the form of DC through high voltage DC transmission. With the development of power converter technologies, we started to think if it's possible to have a DC grid now. Well, the answer is yes, and because the DC grid can be even more efficient than the AC grid. For example, if you're talking about charging your cell phone, if we have a DC grid, then only one stage of power conversion is necessary, and that means higher efficiency, less energy waste, and therefore less emissions from the power generation. With the motivation to make our grid system more efficient and also more stable, lots of investments and research projects have been focused on the future DC grid technologies around the world, of course. And here at U of A, we have research projects in every aspect of the electrical grid system, and we have also developed new technologies to provide stable power to every home so that people won't be affected by any blackout events. And to better transfer our research into real world, last year we started up a spin-off of U of A called Electronic Grid Systems to commercialize our microgrid solutions to provide low cost and high efficiency all-in-one solution for home and business owners. And with our solution, the payback period will be much shorter, and also the system can be easily transformed into a DC grid without any additional cost. Well, currently we're a small team, but with lots of support from U of A, government of Alberta, and also government of Canada. And we're determined to make DC grid happen sooner, so don't feel surprised if you see a full DC grid in Alberta in the next 5 years. With that, thank you for watching my talk, and I hope you all enjoyed this video.
And that was the amazing research that our three speakers have been doing. So I'm going to invite all of them on camera, and I'm going to stop sharing so that you can actually see everybody. And Kenneth, how this next part's going to go is Kenneth is going to lead the discussion. I'll be sharing your questions, so feel free to post them in the chat. Anything you're interested in, whether it's about the research, about the process of starting a startup. And we're really going to have a great discussion tonight because this research is amazing. Zhongyi, you said something about a revolution in the grid system that we're seeing. And I think from all three of these projects is that we can see we're undergoing a revolution in all three of these areas, from biofuels to batteries to the grid. Everything is changing. So I'm going to pass it on to Kenneth to lead this discussion. Do you have anything you want to say just before I give the first question?
Yeah, I think just building on what you said, Valerie, I think what's really great about the group of individuals that we have here this evening is it demonstrates the diversity and the complexity of energy systems. When we're talking about future energy systems as a program, one of the things we often have to do is explain the word system at the start. And that word in this sort of research and scientific context really relates to the fact that it's all interconnected, that it's not just about the fuel that power goes into our planes. It's not just about, the solar cells. It's about how do you store it. And then it's also about the control systems that allow us to connect those sources of energy into our daily lives. Because when you think about all those steps along the way, there's a lot that has to happen. And so it's really excellent that we have three people here who can speak to different parts of the process this evening and demonstrate how complicated it is, but also how we're making progress in a lot of different areas. So Valerie, start throwing us questions and we'll have a good discussion.
Sounds great. And this is a question for everybody. How does being in Alberta affect your business plan? Or in more general, how does being in Alberta affect your research?
That's a really interesting question. Anybody want to jump in first? Because I think we'll go to everyone with that one. Yulin, you want to go?
Yeah.
Oh, sorry,
I think sorry, Kenneth. Well, I think I'm just answer those questions, and hopefully someone can follow up. So I think being Alberta is pretty good because we're a energy-intensive province, and we have oil and gas, and also we have very good renewable energy resources. If anybody didn't know this before, we have the best solar energy resources in Canada. We have the almost the best wind power energy resources in Canada as well. So being being Alberta is pretty good for renewable energy market, of course, and also for research. I think, University of Alberta is one of the top universities in Canada and also in the world. So being here, we have lots of research projects available for us to doing the state-of-the-art research. I think that's pretty good. Hopefully I answer your question.
That's great. I'm just thinking about what you mentioned last. I can speak to, well, I think anybody in Alberta who's gone south and been in the Pincher Creek area and seen all those wind farms will realize that there is such a huge wind resource here. And I believe Southern Alberta also has a great solar density as well. And so absolutely, the amount of opportunity to see projects in the field here is pretty spectacular. That being said, having University of Alberta's logo on my business card, I also have to agree with you that we are one of the best universities in Canada, one of the best universities in the world, and there are a lot of unique resources here that make research possible. That makes me want to ask Bing a question, because I know, how has you being at the University of Alberta helped you and the group that you've worked with in research pioneer new battery technology? I know you've also worked on solar technology. Oh, I think you're muted.
Yeah, sorry. So I worked with Dr. Jillian Burek for many years. I came to Alberta in 2011, mostly because of her. She is, like I'd say, is a world famous scientist in the renewable energies. So in the past years, we actually see big change in the renewable energy world. So initially, we have focused more on the organic solar cells, and also we developed another research direction as a battery, because we have seen this transition into, more and more focus has been focused on the renewable energy. We'd like to combine them together, like for example, for the light to electricity. But when we incorporate this into everyday life, we still need a battery to build them together so we can use it. So store the sunlight to electricity during the daytime and use the battery during the nighttime. I think, that's basically my journey. And I think being an Alberta, we are greatly supported, especially through the FE. Also, University of Alberta give us a lot of fund to support the research on the renewables. So we are really grateful for that.
Well, it's excellent work. And so it's very easy to justify giving it lots of resources because, like you said, the work is definitely world class. And so, Yling, I mean, obviously, Dr. David Bressler is doing amazing work in the biofuel space and has been up until now. And then this move into biojet fuel, I gather, is relatively recent. But from your experience, how has being in Alberta working on a biofuel in a province that's so known for conventional fuels, has that been helpful or difficult?
Yeah, that's a very good question. In terms of this biofuel development, it has been a long and very attractive area that is not within Canada, but also worldwide, because the world is actually facing the shortage of this energy resources, but also at the same time, there's a need for the green energy that can have contribute to the reduction of the greenhouse gas emission. It's particularly here at the University of Alberta, we have a very good research community. It's also the fast community here, Future Energy System. Probably for the people who don't know, actually in our fairs, we have a very good community online that we can see each of our members, their working areas that we can reach out to and collaborate. And there is always very exciting new projects that can be generated in these discussions and also the connections. And I believe this is one of the key reason for the success of the University of Alberta in this novel energy or green energy development.
I would just want to piggyback on that actually, and sort of raise a question that's sort of a little bit self-serving, but one of the things that Valerie and I enjoy most about doing events like this is we liken it to assembling the Avengers in those movies, because we get to bring together some real stars from very, very different areas. So obviously we have electrical engineering here, chemistry, we've got biofuels work. So do you find are advantages in being able to interact with people who are working on completely different parts of the energy system in completely different academic disciplines? Do you find that's helpful in your research? Anybody can take that. I think Elaine, go for it.
Oh yeah, definitely. I mean, there's always a concept that calls the technology transfer. That is some of the technologies that has been developed in one area. The concept or the principle of that can be easily transferred to another area that has not been well developed. For example, for the one very good example is the IT technology, that they will use a lot of the codings and modeling systems. It will making the management and also the grid design and material designs much easier. And it will, in this case, you don't have to do a lot of the lab experiments, but in this case, just to focus on something that is more promising and has a greater potential to be commercialized. Or, for example, the simulation will tell you like which formulation or which direction, which combination can give you a greater success in terms of the higher energy density of a material, or like a higher property of a fuel that can be used in your gasoline engine. Or that's my answer to that.
Very good. Does anybody else want to weigh in? We're getting a lot of questions in the chat box, so we probably should address some of them, and I should be quiet.
Yeah, I think I'll just give you a quick answer to that. I think we have a very good multidisciplinary research environment at UFA, because just speaking for myself, we have done some research collaborations with mechanical engineering and with also material engineering. For example, there are other professors developing batteries as well. So they're making new batteries, and we're developing battery management strategies, chargers for them. So that's a very good combination.
Excellent. And I didn't know, Ping, if you wanted to weigh in, or should we go to some other questions?
I can give a very short answer for that. Yes, we are also doing multidisciplinary research. Like I've worked with Department of Chemical and Mechanical Engineering, and also with ECE department as well. The research community in the U of A is really collaborative and supportive to each other.
Awesome. So I think we've done our duty now talking about the University of Alberta. Valerie, let's actually talk about some technology.
Sounds good. There are definitely some experts in this audience based on the questions that are being submitted. So this question is to Zhang Yi. Where do you see DC grids or microgrids being adopted most quickly? Is it a technical barrier or more one of policy and jurisdictional barriers to adoption?
Well, that's a very good question, actually. So we're actually seeing microgrid being built across the world, and we are also we have pilot projects in Alberta as well. Well, that's for, let's say, for AC microgrid. Well, for DC, we probably will have to wait for a little bit, because there are some regulatory issues, because there are no DC in your wall outlets, right? So to have it as a standard power supply, we have to work on the building codes, safety codes, and everything related to safety, because we don't want to burn the house, right? So there are lots of work to do for sure, but we are getting there, and it's happening.
That's a really interesting question too, because obviously the technology you're working on is very situated somewhere. You are putting, you're attaching it to something that's in the ground. I guess for both biojet fuel and batteries, they're much more mobile. Has there been any sense, Yiling or Bing, as to whether there's parts of the world that are moving more quickly to adopt those sort of technologies, or a bit more interested in them?
Yeah, so as for the adoption of battery, I can divide them into different streams. Like for portable electronics, that's like it's adopting everywhere in the world, right? We see from our life, we have been using cell phones more and more, laptops more and more. And so this is happening all over the world. And as for the energy storage for the renewable energy, I think most adoption has been seen in Europe and the US. And as for the electric vehicle, since 2015, as Tesla has announced their Model S to the world, I see the adoption of electric vehicle has been increasing over the years. But as I don't know if you have been to California, you will see a very big difference. Like in California, you see a lot of the electric cars on the street. But here in Alberta, I remember I've only seen 3 Tesla cars on the road in Edmonton. So that's a huge gap and a huge difference. Also, that's related to the weather, right? Because half of the year in Edmonton, we have snow. The electric cars may not work very good in the winter time. That will require the researchers to develop more batteries that can adapt to the cold temperature. But also there is some policy related issue, like for example, like I said, the United Kingdom, California, Hainan province in China, the automobiles. So that kind of accelerated the adoption of electric vehicles there. So I would say, well, we see this explosion between here and there. As for the research side, like we have excellent battery researchers in Canada, like Dr. Jeff Dan. He works closely with Tesla in developing the next generation batteries. But there are more scientists in the US and Asia working on the batteries. I think compared to them, Canada still have a long way to go. We need more support to the university, to the researchers, to the grad student to work on this, revolutionary technology and use it in Canada.
I would just add on the point that you made about only seeing 3 Teslas. We have snow half of the year and then massive potholes for the other half of the year. So I would be a little bit reluctant if I had a brand new Tesla driving around on the roads, because you don't know around here. Yiling, did you want to weigh in on biojet fuel?
Yeah, sure. Yeah, just recording Bing's talk that the cold weather in Alberta it creates an opportunity for you to develop a brand new Tesla technology here, particularly for the Alberta market. Yeah, and for me, it's the same for the biojet fuel, because the fuel is going to be used at an extremely low temperature, and there's a need to modify its property that can transform the jogging diesel and modify it in order to adapt to the environment that is going to be used. For our biojet development, if you notice that one of our collaborators that are listed in the video is Edmonton International Airport, and we really appreciate this great support from them, and they give us much insights into the regulations that can be used in the aviation system. So we've been working collaboratively very closely with the industry, and for the development of a technology that has a real use, we definitely need to working with the one that is provider that is currently supporting this system and know what they need and to provide real solutions to deal with their questions. Yeah, that's it.
Exactly. And I imagine that question of how do we interact with industry and bring research solutions to them will probably come up in this discussion. But I'll throw it back to Valerie for now so that we can make sure that we're answering the questions.
All right, the next question is for Bing. What energy density is obtained with the new lithium-ion batteries in development? Oh, I think her camera might have froze. Okay, we'll come back to this question when she unfreezes. Yiling, a question about where you get your waste materials. Does the U of A collect grease or used cooking oil for their research? Is there a collection spot on campus? I'm guessing this is somebody from the U of A campus who wants to know what the heck to do with their waste cooking oil.
Yeah, if you came from the U of A campus, then definitely, yeah, one is from the SUP, the Student Union building, that is at the back of that. And also, we also collect the waste grease from all the municipal waste lines. I mean, in Edmonton, we've done quite great in our waste or the garbage classification. We finally classify different types of the waste into different streams, and as a kind of like an extension, talk to this, like that is one of the reasons that the successful of the Anachem they developed here, as they actually like the way like the Edmonton has been done great in this job.
I love the fact that I can eat fast food now and think that I'm saving the planet using biofuels. This is a great benefit for me now. Burgers and fries for everyone.
Just everyone, all of the fries. It's going to be great. Bing, is your camera working again? Awesome. Okay. I'll repeat the question from before. What energy density is obtained with the new lithium-ion batteries in development? And you're still muted.
Yeah, that's a very technical question. So I don't have a clear answer because you refer to the newest lithium-ion battery. I'm not sure you are referring to the research side or the industrial side. I can give you some insight. So from the research side, we can make the energy density really, really high as 2,000 or even 3,000 milliamp hour per gram, using some nanostructured electrode and nanomaterials. But the problem with that is the large scale production is really hard. So in the industry, the energy density is way less than that. But I can tell you the most advanced battery for in the world right now, like the electric vehicle used battery is the one they call the million miles battery. What does it mean is scientists have been tested over I think more than 3,000 cycles. So it went through 3,000 charge and discharge cycles in the past 3 years. And with that test and with the battery setting, the total the total electricity that have charged to this battery can run the car more than 1 million miles on the road. So that means if you buy electric car, you use this battery, you can probably use it for 25 years without a change of the battery. That's gonna be the future.
Wow, that's a lot. Thank you so much. You might as well stay off of mute for a second, because I think our discussion of batteries has made people really interested about the electric buses in Edmonton. Mm-hmm. So one of the questions was, are transit agencies interested in these battery improvements with regards to all these electric buses that are being purchased, especially in Edmonton? I believe the goal is to switch to electric by 2030.
Yeah, so I don't know. I'd better like ask them. I want to know answer from them, right? But I guess like if I were them, if I want to like use the electrical buses to replace the current bus, I'd want to say the batteries can have higher energy capacity. So in one charge, it can run longer, and also the battery can have a long lifetime in Edmonton winter. It's like your battery needs to be like a charge and discharged for thousands of times. So these cars can be used for years, rather than you use it several times, it stopped working. So it's a waste of taxpayers' money.
Thank you so much. And thank you everyone for all these questions. There are some great questions coming in. So one of the next questions that I think is for everybody is, what's the current timeline for putting these different projects to use in Alberta?
That is a really good question, and I think it gets to that industrialization question. So yeah, let's go to everybody. Why don't we start with you, Zhangyi, because I know, I'm imagining it must be challenging when you're working with a grid system that's been around for a century to try and actually move new control systems into that.
Yeah, it's pretty challenging because you have to bring the utility companies on board if you want to do something big, right? But we start from the tiny things. We start from homeowners, business owners, from coffee shops, department stores, and also farms. So right now it's happening, and we're implementing our microgrid controller in some solar farms and solar battery systems in Alberta. And so I think we're just doing that, and it's happening. And also, I think I'm gonna circle back a little bit to talk about the electric vehicle and also electric bus, because the Proterra electric bus, they need chargers, right? And those chargers we're developing at U of A. Yeah, so it's kind of a commercial development. So probably in next 3 years, if all those buses are running on the street in Edmonton, the chargers will be all from U of A. I mean, research and developed from U of A, and it probably will be manufactured from other manufacturers. But you know that the original technology comes from U of A. And also, I think to solve the problem of electric vehicles, we need a charging network, very densified charging network, and that's something we're working on. So just imagine if you went to Tim Hortons and then you just stop your car and put in and plug in the charger, and then wait for example 15 minutes and come out, the car's full. So yeah, that's what we're doing now. And
that's incredible. I mean, you identify sort of changes that will happen in our day-to-day lives. You go to Tim Hortons, you stand in line. By the time you've managed to get back out, there you go, your car is charged. But it's really interesting. And I mean, it must be rewarding to work on something and see it integrating into everybody's daily life, which I guess also must apply in the biojet fuel realm. I mean, anytime you have to take a flight, not right now, obviously, owing to the situation in the world, but is it, you mentioned before working with the Edmonton Airport, Yiling, is helping you identify how, what regulatory issues you have to deal with, or supply issues, or even logistic issues. Why don't you talk a little bit about what sort of things you have to learn as you're developing a jet fuel alternative?
Yeah, definitely. For this biojet project, we've been developing this biojet fuel from the Greece for more than 1 year so far. The early communication with the Edmonton International Airport is mainly focusing on the specifications of the product that is suitable to be used for that engine, for the aviation engine. But definitely before our product can be formally enter into this section, they definitely to be passed a more comprehensive evaluation from all these government authorities. I can give you one example that is based on our previous development of the drop-in diesel. We've been developing this drop-in diesel for around 10 years, and the initial patent was actually issued about more than 10 years ago. And now it has come to a startup called the Forge Hydrocarbon, and it's also in close collaboration with the very world-renowned Shell company. And yeah, we've been working very closely with industry, and there's a great opportunity.
That's excellent. I mean, it really illustrates the amount of work that needs to go in from the patent in order to sort of bring things along to be able to get them into our daily lives. When you're looking at bringing your new anode technology to market, do you think you're going to want to work with an industrial partner, or is it a case where you patent it and license it to different companies, or do you have a sense yet of what will be the best approach?
Currently, our strategy is to partner with industry.
Makes sense. Very good. Okay, Valerie, another question?
Okay. The next question we have is to Yeling. So one of the common challenges of biofuel is the source of material, using crops for biofuel rather than food. Your research deals with that by using waste materials. Due to that, do you find that you have greater support for this type of biofuel than maybe the more traditionally thought biofuel?
Sorry, I don't really understand the content of this question. Does it mean that how is the availability of the source of the biofuel that we've been developing, or?
So rather than using crops, you're using waste material, and that does that make the public and industry like the product better because you're not using that food that could be used for food instead?
Yeah, definitely. I mean, to other audience who may not know that there's been always a food and fuel debate. This is always something that we've been considering in the development of the bioenergy. You may have heard of the first generation biofuels that is actually essentially developed from something that is edible. So it means that if you are producing first generation biofuels, you're actually making that in exchange of a food for that. But in our technology, we are focusing on a second generation biofuels that is converting something that is not edible. So we will not sacrifice any food in this process. And in this case, we can also generate fuels and values to the industry and the society.
Awesome. Thank you so much. Sung-Yi, can one power converter do all four of the scenarios that you mentioned, or are they specific? For example, only AC to DC, but doesn't do DC to DC, or is it all of them in one power converter?
Well, theoretically, it's possible. Well, I guess if I'm still a PhD student, I probably will say it's a good solution. But as a startup now, and I think, this is speaking for myself, I think it won't be a very good solution because economically it's just it costs too much. In most of the applications, we only need to use from DC to AC or DC to DC. So it's kind of DC to either DC to DC or DC to DC. So maybe some applications do require two kinds of conversions in the same system, and then you can use both. But yeah, and to answer the question, theoretically it's possible, and it's already being done in some of the research.
That's a really great answer that sort of leads into something that I was going to try and find a way to lead into later. But you made a great point that as a PhD student, if you were asked that question theoretically, you could say, of course, we can do this. But as somebody who's launching a company, you're thinking in terms of, should we do this, or does it make the most sense to do this? And so I guess this is a question I want to put to all of you. But as you're working sort of at that commercialization end of the research spectrum, have you noticed differences compared to when you got started, say, in your PhD studies, in the way that you think about the problems that you're approaching? Like you're thinking not just about how that it is possible, but the practicalities. Is that something that you've noticed changing over time? I don't know if Bing or Yeleng, you want to speak to that first.
Yeah, I'd say it's very, very different. So as a PhD student, we want a perfect product, a product that is amazing. All kinds of quality is amazing. But when I go to industries like you don't want to build a perfect product to present to the customers. You only need your MVP, the minimum viable product, to show to customer and really ask what is the quality they are asking for and what is the quality they are looking for. And then you work from there. Maybe like as a PhD student, I may work years on one property of that particular battery. I feel amazing. This is amazing. But when I present to customers, they say, I don't want it. So that's, I think that's a key, like a main change, switching the journey between a graduate student to an entrepreneur. It's really need to be customer focused.
Very good. And Yeleng, you same sort of reaction?
Yeah, I mean, recall my experience as a PhD student. I mean, I'll be usually always just think big, something that I can develop a technology that solve all the issues or all the problems that is present, and I will try to deal with that. But sometimes one thing that the academia always forgot is that the cost of the technology or the commercialization is not always the priority, but that is for the industry. As for the academia and research, I mean, their job is mainly focusing on developing a solution. Whether or not it is economic, feasible for the current society, for the current industry, maybe is less prioritized in this case. But there's always a need that we are always looking for something that is maybe not currently used, but have a potential application in 10 years, in 20 years. One very good example is about the vaccine development for the COVID. Actually, the initial technology for the COVID vaccine can be dated back to 30 or 40 years ago. For the messenger sRNA, these kind of macromolecules. But actually until for example, only then 10 years ago, when the SARS came, and this technology has the real applications. And now, within 1 year, and we have these vaccines for the COVID.
Yeah, so in some ways, the fundamental research early on proves that a thing is possible, but it might be a solution to a problem that hasn't really emerged yet. And I think one thing that's worth pointing out, I mean, as much as you just all pointed out how as a PhD student, you're thinking big and you're focusing on something, but credit to all of you and to your supervisors and your groups. I mean, you're all very close to having finished your PhDs, and yet you're already thinking in these terms. So I think, I mean, Zhang, you made the point that those chargers for the buses, they're being developed at the U of A. So I think it's fair to say that U of A researchers do have an understanding of the importance of both that fundamental research and the fact that there's going to be people asking those immediate questions. I think, is that fair to say? I mean, it's probably a...
Yes, you're definitely right. I think it's kind of depends on what kind of fields we're talking about. Because as the engineer, we're electrical engineering, so we have to work close with industry, even we're PhD students. So we have to, I mean, cost is was not obviously the first thing on the list, but it's definitely on the top 5. It's definitely one of the top 5. So we have to keep in mind that well, if this is, costs too much, it won't be a good solution. So yeah, so I think it depends on the field, and we worked closely with industry when I was a PhD student.
Very good. Valerie, more questions?
Yes, and as we talk about that jump from PhD student and research in the lab to, in this case, 2 new companies and 1 maybe future new company, one of the questions we got was, what are the resources available for you guys to kind of make that jump from research to industry? What exists in Alberta for those startups?
Does anybody want to take that on first? I'm particularly looking at Pingyin Zhongyi because we should talk about the Green STEM program at some point. But
Yes.
Does anybody want to jump in?
Yes, I can take the lead. So first of all, I'd like to thank Kenneth very much. So right after my graduation, there is that program called Green STEM, Green STM, which supports Alberta-based startup companies to commercialize technology from the university. At that time, Kenneth worked for the FES and I was part of the FES. I think he's the one I got this message from in the first hand, and he actually helped me prepare for the application for the Green STEM project. Even the first one wasn't very good, but I was lucky I got into the second cohort. So Zhongyi are also in the second cohort. We just started in July 2020. So I'd say this program is really good for us as a new graduates. New PhD graduate from U of A. This give us some. It's a 2-year program, covers the salary of the founders and also gives some commercialization fund to support the company to go. I think that's the biggest support for me to take this transaction. And also, as I step into the entrepreneurial community in Edmonton, I found the community is actually being very active and supportive. There is a certain groups like Startup Edmonton, also Startup TNT, and these groups, they organize events for networking, and through that I met a lot of people in this area, and they are all very kind and being very helpful. Like whenever I have everyone's like, oh, whenever you want to reach out, whenever you have a problem, just get back to me and we can talk over it. I think that's very, very good. And also recently, actually today, there is a new program launched between the U of A and the Brainstorm Ventures. It's a new program that's going to help U of A research to commercialization. From that, so that program is going to help the research from the U of A and the researchers who want to market their product from U of A to go to the market. That program brings a lot of experienced entrepreneurs, and they can meet with the startup in a 2 months. They meet every 2 months, and they can bring insight to the startup, give advice, and help the startup along the way. So overall, I think I'm very grateful. I got the Green STEM program, and I have awesome people to help me. But also, I see the culture of the commercialization around the university is getting better and better, and it's very supportive.
Zhongyi, has that been your experience similar to your experience as you've been starting up?
Yeah, very similar, because I'm also in the cohort 2 of the Green STEM program. And one more thing I want to add is that we actually have a very good startup, or let's say entrepreneurial environment in Alberta, and there are other investors, very good investors. They're trying to bring a similar model in Silicon Valley into Alberta, in Edmonton, Calgary, and we have lots of investors, and they are very supportive. So I kind of encourage, graduate students and PhD students thinking of, starting up a company, trying to commercialize your technologies, developing your research, and that will be an awesome journey.
And you're saying, obviously, because David Bressler has been working on developing his companies for so long, you're sort of joining an environment where that process has been going on longer, but even just as sort of looking into the future for both Bing and Zhongyi, what can you say about what the experience is like for you working with a company that's successfully spun off?
Oh yeah, definitely. I've been quite excited about Bing and Zhongyi's progress. They have great success in their startup company. And for myself, yeah, definitely I'm excited and have been inspired to work on these directions. And I think it's with the supervision of Dr. Bressler, and I think the biofuels, developing this technology from these waste materials, it definitely have a great potential and can have the opportunities with industry, particularly based on the current collaborations with the industry and the end user.
Excellent. All right, Valerie, I think we can go to another question.
Awesome. Just going to say, it's great to see waste materials being used. My whole PhD was on waste materials for land reclamation. So waste materials, it's a great place to get cheaper products and use something that then doesn't need to be managed in another way. Bing, question that we've got a couple times actually, so people are really interested. What's the cost difference between this new type of battery that you're creating, your anode material, and the more traditional graphite material?
Yeah, that's a really question because like Zhongyi said earlier, when you go to industry, the cost is almost the number one in the queue. So I'd say like we did a rough estimation, even though our raw material compared to the graphite is a bit costly than the graphite, but taking the simplification of the manufacture process, saving the human time and the energy, and there is no organic solvent used, so there is no cost for the recycle of the organics. So our rough calculation shows the cost is going to be similar with the graphite.
And actually, I just wanted to jump in when you mentioned that. Not using an organic solvent, does that mean the process is more environmentally friendly as well?
Exactly.
Wonderful. Zhongyi, a very complicated question, at least from my perspective of not understanding. What is the converter max voltage and power in watts rating that you have developed? Is it comparable to the recent development around the world? We've got some experts in the audience today.
Yeah, so the converters we have now, the maximum voltage is 1500 volt in DC. That's 1500 volt in DC and 800 volts in AC. And we can go lower voltage, of course. And also the power is 100 kilowatts. So that's 100,000 watts. And because our focus is not on the very large scale solar farms, so in those solar farms, the converter will be very powerful, like 1 megawatt. But our focus is mainly on smaller scale systems, like residential and commercial. So our converters are enough.
Sorry, I just want to jump in with a follow-up there too. Just out of curiosity, how large or how heavy, like when you say something that can handle that many watts, is it the size of a building? Is it the size of a bread box? Like, just sort of help me visualize how big it is.
Well, that's a very good question, and we're actually trying to build them smaller because right now, if you see a 100 kilowatt converter from other manufacturers, you probably will see somewhere around 1 meter long, high, 50 centimeters wide, and 30 centimeters depth. So that's, and the weight is around 100 kilograms. So that's pretty heavy, and you probably will need for technicians to handle one converter. But we can make those converters 10 times smaller. So probably the size of a laptop with a little bit of height. It's will be thicker, but the size, the surface size will be similar to a laptop for a 100 kilowatt converter. So one technician can probably handle two at the same time. And the weight is, I think the number we have right now is sometimes lighter. So that's 15 kilograms or something, 15 kilograms.
I haven't been to the gym for a while, but I'm pretty sure I could even lift that. So that's good progress. And I mean, it sort of raises another question because you mentioned cost is number one, but you're also making things practical, making them practical to use. And so being, like you said, having a process that doesn't have multiple steps involved and human inputs into each of those steps, having something that one technician can install, and then like these practical considerations must also be something that industry is interested in.
Yeah, that's something, I mean, just from my end, this is something that the industry has been working on for a long time. And the reason we started up with this company is because we had a breakthrough. That's something that other companies did not achieve. So we actually talked with lots of EPCs, that they are contractors installing solar panels, installing solar inverters. We talked a lot with them, and they really like the idea, and because that will save their time, save their money, and also solar farm owners can save lots of initial investment. And I think that's the main reason we started this company.
Right. So size equals time and people, which equals money. So at the end of the day, it comes back to money. I stand corrected. Valerie, I think we're good for another question.
Sounds good. Yeling, a question from the audience is, how is jet fuel different from car fuel? And how does that, is your research with these biofuels for jet fuel, can it be related to car fuel in the end as well?
I would say that that's quite a professional question. Yeah, for this question, I would say for most of the car fuels, we call it gasoline. And for the gasoline, it actually covers the carbon number is actually lower than that of the jet fuels, which means that it can be easily expanded and vaporized. That means that it can easily form into a vapor that can be ignited in the engine and provide the force. While for the jet fuels, their carbon number is in between that of the gasoline and also the diesel. So it can be suitable for use in for the aviation engine. And a particular property, a special property for that jet fuel is that it has a lot of the branches. As I mentioned in the video, there's a lot of branches and side groups. So it has a good flowability at low temperature. That is a major difference between these two different fuels. For the car fuels, it can not be directly used as aviation fuels, definitely. Yeah.
Awesome. Thank you so much. We're probably have about 5 minutes left for questions. If you do have any more, make sure to put them in the chat box. We did have a question about space. So Bing, do you think that your batteries have the potential to be used in outer space?
The short answer is yes, it can be used in space because there is no restrictions of its application. But in a practical point of view, I want to use it in the space because it's not designed for the space. Because for the space, you want it's kind of different from the industry, like the regular industry, right? For space, you want a super lightweight, and even its cost is okay because the weight itself also it will cost a lot to bring it to the space. For the space application, I would recommend those batteries which uses nano-structured material. Even the cost is very high, but the efficiency is also very high, and they can be integrated in a smaller space. So yeah, I would recommend that. So my product, okay, you can bring it to space and use it, but I won't recommend it.
Yeah, I think this part I can also add something words on this. As being mentioned, a very good point that there's always a need to understand your end user's demand in this case. For the applications in the space, you may want to invest 200 more or 2,000% more in order to have an increase that is only 10%. You don't really care about the cost for that. But for our daily use, you definitely have to make a budget. Like, is it worthwhile to invest this amount and get that benefit?
Yeah, in a place where if something goes wrong, you end up in a movie with Tom Hanks, you are going to spend the extra money in order to make sure that you don't have a problem. That's a great point. Valerie, if it's okay, since we're in the last 5 minutes, I'm going to pose one of those big thinking questions to everybody. Does that work for you?
Sounds good.
Okay, so this one for everyone. But obviously, we've talked a little bit about your journey as graduate students and now moving into the world where you're commercializing technology. As you think back to when you got started and you decided to pursue your PhD, for instance, did you see yourself moving in this direction, or did you imagine yourself going a different direction? And whatever the answer to that question is, are you enjoying the path that you're on now? Do you find it rewarding? So I'm putting everybody on the spot. Who wants to go first?
Well, I'll go first.
Okay.
So, yeah. And well, I actually wanted to be a professor in the beginning, and that's why I did my PhD. And but you know, as I moved from a fresh PhD student into third year, fourth year, and I worked a lot with industries, and then I realized that there is a very good opportunity to start my own company. So that's how I kind of detoured. But honestly, I love research. I love doing research. I mean, I can spend a whole day in the lab and eat in the lab and even sleep in the lab. And it's kind of joyful for me. But right now, it just kind of opened my mind. I can also be an entrepreneur, and that's kind of explore my potential.
I'm sure nobody will complain if you eat in the office and sleep in the office too. I mean, it's your company. You can do what you like. I mean, no judgments. It's okay.
Yeah,
no,
right.
Not in the university lab. You can't eat in a university lab.
Well, we have a kitchen.
PPE and masks.
Oh, yeah, you're definitely right.
Bing, do you want to go next?
Yeah, so when I started my PhD, like Tony, I also want to be a professor, but but I thought my journey will be I'll become a professor first, then I do some interesting research. If I find something that is useful to the industry, I will probably commercialize it. But I didn't expect the entrepreneur journey come so early. So it's kind of a surprise to me. And so far, I enjoy the entrepreneurship very much. I think it's a totally different journey. It gave me a different mindset than a grad student. And like every day it's about exploring. But for a startup company, it's all about try different things and make mistakes, fix it, and find the correct way. I think it's really fun, challenging, and every day is new. But at the same time, I think I didn't give up research. Even as a startup, we are very R&D focused. I think in the future, the goal of a company is not just this product, but continuing developing other amazing technologies around the battery or even some other devices in the future. So I think I will still stay very close to the academia, whether as in a company or as a professor. That's my interest, and I hope this research, like Zhongyi, me, and Yeling, we've done, can do a little contribute to the world a little bit, like make our life a little bit better. And that's how we return to the society, right? Like we've spent so many years to study and get so many resources to support our career. And now it's our time to return. Yeah.
Brilliant. And Yeling?
Okay, to me, a PhD is like more like training progress, a training project that this plays the period of time that I got trained to think about a problem, have the ability to identify what the problem is, and to identify what is the best way to solve it with all what I have or what we have the technology at present. So I think PhD is kind of more like a training process and get you better prepared for your future careers. It can either be professional, like a faculty in a university. It can be a scientist in the industry. Yeah, and for me, it's quite valuable.
Excellent. So I guess we're just about done. I guess one last question for everyone is just what are the next steps with each of the technologies you're working on, obviously with the companies you're starting? What are the things that you're going to be focusing on in the next, say, 3 to 6 months for each of you? Why don't we go in the same order as Zhongyi? What are you working on in the next few months?
So we're working on piloting projects. So we have partners, they are willing to pilot our technology, and we're looking to, have some pilot projects and scale up and, get going from there.
Awesome. Bing, what are you going to be focusing on?
Yeah, the first one, file the patent, we're in the process. And the second one, finish our MVP and talk to customers, find that product market fit.
Awesome. And Yeling?
Yeah, we've already identified some very good formulations and conditions to produce the biojet fuel, and we have been working with for hydrocarbon. And so in this case, we can scale up from our current 1 liter reactor to their continuous reactor that is much larger and closer to the commercial scale.
Fantastic. Well, wishing all of you the best of luck with all of the next steps that you're taking. I'm looking forward to the awesome stories that fortunately Valerie and I will get to hear before anybody else, and then we will make sure that other people hear about them too. But I think that's it for my gabbing. Valerie, I'll turn it back over to you to tie a bow on this.
Thank you so much, Kenneth. And thank you to all 3 of our amazing researchers and speakers tonight. Seeing as no one else is unmuted, I will clap wildly. Everyone else is clapping wildly at home. That was such an exciting presentation to get to see 3 technologies that are really going to make a difference in the next few years of our lives. And that's really what the research at Future Energy Systems and what you guys are doing. And it's amazing. We're getting so many thank yous in the chat box. And I just want to say really quick before we sign off, if you are interested in what you heard tonight and you want to hear more, check out our next 2 talks. The next one is on February 24th, The Big Picture, Modeling the Global Energy System and Everything Else with GCAM. And then on March 24th, Stephanie Ibsen is going to be talking about soil invertebrates, small but mighty, and how we use them in land reclamation. You can engage with Future Energy Systems on our website, Twitter, Facebook. You can email us, check out our YouTube channel, subscribe to our newsletter so you find out about all of this amazing stuff. And thank you all so much for joining us tonight. I believe Cassidy is going to come on from the Edmonton Public Library.
Yes, thank you, Valerie, and thank you to Kenneth and all of our speakers this evening. I always learn so much at these events, well beyond what I think I would have been picking up otherwise. So thank you. I just wanted to share that I will be sending out all of the links that we threw in the chat. So for all of our speakers, there was some links to find out more information about their projects, as well as more information about future energy systems that will all come in an email to you. So you don't need to worry about frantically writing it down right now. And I will also send out a very brief survey. So if you have a few moments, you can send us some feedback. We really appreciate it.
Awesome. Thank you so much, Cassidy. And thank you again to our speakers. It's been a wonderful night. I hope everyone stays healthy, stays safe. If you do have any questions that you didn't get answered, we will be around for a few minutes, so you can pop up on screen. We will delete it from the final video, so you don't have to worry about that. But we'll be around for a couple minutes if you do have any last minute questions that you'd like answered. Thank you guys so much. Have a good night.